Yeah, this today's session we are going to discuss the Apple's paper, The Illusion of Thinking, and this the outline. First, we are going to discuss the paper itself. Then there's an anthropic, very short paper called The Illusion of Thinking, which disagrees with the Apple's paper. And I also did some very simple experiments, um, kind of reproduced a little bit of the Anthropic's small paper. Uh, Also, I put a related reading that's also from Apple. I think it's from the same group. I saw common names on the papers. I was worried that the Apple paper doesn't have enough content to cover the 1.5 hours. So let's see. So first, the background. They said that the current evaluation of the reasoning models, they primarily focus on mathematics and code. So they might suffer from data contamination and might not provide enough insight into the reasoning structure and quality. And with this paper, they want to find these things. Basically, are they capable of generalized reasoning, or are they just another form of pattern matching? I think this one they also discussed in the previous paper, which is the GSM Symbolic. This one is from last year, and they also want to perform the does the performance scale with problem complexity? So that means if the problem's complexity goes up, how does the performance how does the performance change? And they want also compare the reasoning models to their non-thinking counterparts. Uh, and also, sorry. Uh, okay, yeah. And the last is they want to find the limits of the current reasoning approaches. Uh, yeah, actually, I'm not sure if they reach this point from my reading. This is a very deep topic. So the methodology of this paper is they use the controllable puzzle environment, which means they use four famous puzzle games: the Tower of Hanoi, checker jumping, river crossing, block word, and all of those puzzles they can change the number of entities in the game. So when you increase, for example, when you increase the number of discs in Tower of Hanoi, the complexity of the game will increase. And also, yeah, they use the thinking models and their non-thinking counterparts to do the comparison. Basically, they use two model families, the Cloud 3.7 Sonnet with its thinking and non-thinking parts, and the DeepSeek V3 and R1. Also, they use a simulator to verify the solution because the solution is easy to verify but harder to come up with. Yeah, these are just famous puzzles. So I actually found something online. This is the Tower of Hanoi. I think everybody should be very familiar with. So it basically require you to move the pile of disk from the pole from one pole to another pole. And the restriction is you can only move the top disk and then you can put onto another pole. And then when the disks are piled together, it must be sorted uh, by size, which means the smaller disk should be always on the top. So yeah, the solution is very like traditional. It's just if we were to do it, it's just a recursion. Um, but for language model, it it will kind of do the reasoning on it. Uh, and the second one is the checker jumping puzzle. So this one, there's a like n of blue disks and n red disks, and they are putting into the grid, the one-dimensional grid of the number should be 2n plus 1, and they are lined to the sides of the area and with one empty cell in the middle. So you can only move the green ones to the right and move red ones to the left, and you can only move like one grid every time. And when you you can move to the empty cell adjacent to it, and you can also move like jump over one disk which has a different color. So basically, I think this can be solved by a look ahead search algorithm. Basically, you can search ahead 2 steps, which means this actually how do you say that? In each step, you only have 2 possible moves, which is, we move this one or move this one over here. So if you move here, then basically on the first step, you only have one possible move because it's symmetric. And when it comes to here, you can either move this one or the red one to the left. But if you move the the blue one to the right, then basically this group will be stuck. So it's not a good move. So you need to move the red one to left. And then you have 2 options. You can move the blue one again, or you move the red one. But if you move the green one, when you consider the next move, you will be stuck again. Here, because this is a symmetric situation again, so we can only consider this as the possible move. But here you see these 4 disks, they are stuck already. So the only feasible move in this setup is move this red one to the left. And then you will have the same reasoning, just to move this blue one and then probably move this one again. Yeah, I think it should be something like this. You just keep them interleaved. Yeah, that's the solution. So, and not the the third one is River Crossing. It's also a very famous game. I think a lot of the games are called what is that? The sheep and the herd. Yeah, I'm not sure. Sorry.
Yeah,
But
I
they
think
based.
one variation was like a fox and whatever, a chicken and a sheep or something like that, or I don't know. But the problem is that some of them will eat the other one, right?
Yeah, yeah, that's correct. So basically, the idea is the the smaller the we call it this lowercase a the is the actor, and the uppercase a is the agent. So basically, you don't want the actor to be at the same place uh, in as the other agent. So you don't want to A2 to be on the same side as the agent 2 to be on the same side as actor 1 without agent 1 being the same place. So they're thinking the agent might just want to uh, talk with the other agent's actor, but they don't want this to happen. Uh, yeah, am I clear? Sorry, uh, my expression might not be is not very good. Sorry.
Yeah, no, I
Um,
think that's pretty good. And then it's somewhat intuitive that the more of these actors and agents you have to start with, then the harder the problem is, the more moves it will take to get everything from one side of the river to the other side of the river. That's
yes,
same as the other
yes,
problems. That's how they control complexity, is the number of moves.
yes, and there's a boat in the middle, and on the boat it's the same restriction. Uh, and there's actually a paper about it that when the number of actors and agents, if the number is greater than six, I think we need more boats, more capacity in the boat. Uh, that's actually the Anthropic's paper, one point in Anthropic's paper. So yeah, actually this web page is generated by cloud. So it's interesting. It's actually working. So for this, you can, for example, move two actors to the other side and then maybe get one actor back and then move probably two agents over and then move this agent to here, and then move the remaining two over to the right bank. So that's we solve this number two problem. Um, the last one is called block world. This one is relatively simpler. So basically, you have a bunch of boxes and a bunch of slots. Then they can be arranged in the slots in any pattern. They have a start state, they have a goal destination state. So you can move the box one at a time, and then I think, yeah, that's basically the only restriction. So they also control the complexity by controlling the number of boxes and the number of slots. Mm, okay, puzzles. Yeah, these are the puzzles. Accuracy. Okay, so then they talk about the accuracy of thinking versus non-thinking models. Uh, so these are the four games, and the above one is I think the top one. How do you read that? Number of blocks, accuracy.
Yeah, so the y-axis is how well the model was able to, the LLM was able to solve the problem, and the x-axis is the size. So it's the
Mm.
proxy for complexity.
Yeah, yeah. I just don't remember what's the difference of the top line and the bottom line.
Oh, it might have been the two different models. I don't remember. I can pull the paper up. Yeah, the top is Claude and the bottom is
Oh,
DeepSeek.
yeah, 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 yeah. Thank you, thank you. Yeah, it's two different models. Yeah, thank you. Um, okay, so they compare I think the line with triangle is the thinking model, and the dotted line with circle is the non-thinking counterpart. So they are saying the accuracy when they divide the complexity to three regions, the the least complexity one, and the medium size, and the large size. So basically, com corresponding to different level of complexity. So as we can see in the low complexity region, the thinking model roughly have the same performance as the non-thinking model. At the same time, they will have less computation. And in the medium size region, the advantage of thinking models start to manifest. They have considerable advantage or better performance than the non-thinking models. And when it comes to the more complex, the most complex regions, both the thinking model and non-thinking model uh, perform bad. They call it collapse. So the models just stopped producing correct solutions.
Now,
Okay.
this will come up as we get into more of the discussion, but do you remember their exact definition of what a correct answer is? Because I think that was what some of the criticisms were, is there was a very narrow definition of a correct response.
Correct response. They have a few constrictions on that. Let me bring up think the criticism is about, one of them is about, yeah, the river. Is it a river crossing? Yeah, probably the river crossing one.
So what I remember is that the correct answer requires the LLM to list each of the moves that it would make,
Oh,
right?
yes, 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 yes. Sorry, I misunderstood your
Oh, sorry
thing.
if I wasn't clear. Yeah.
Um,
Um, but there's no other form of answer that was acceptable. Like no explanation, no instructions, you know, couldn't offer to write code. It had to be list out all the moves.
I think they listed the correct for example, they listed the required format of the moves
Hmm.
in this is the system prompts, but they do require that the LLM to list each of the move, and within the move, they need to list the full state of uh, of the board or of the game.
Mm. Hmm.
Yeah, I think yeah, that's one of the criticism.
Yeah. And then I can't remember, did the solution have to be optimal? Did it have to be the minimum number of moves in order to be marked correct?
No, no, they don't require it to be optimal.
Okay.
They just require it to be correct
Okay.
by how do you say that? By conforming to these constraints. Uh, okay. Accuracy and the thinking tokens. They then investigated the relationship between accuracy and the tokens, basically the computations. Um, Complexity, accuracy. Oh, this one above one is the thinking. This the above one still is the complexity. The x-axis is the complexity. The y-axis is accuracy. The second, the bottom row is the complexity versus thinking token. So I think their point is that when the complexity goes up, initially the thinking tokens goes up, which is intuitive, and then up to some point, uh, when the complexity continues go up, the thinking tokens actually goes down. Uh, that I think they thought that might indicate the models stop stop to think. Mm, I think, yeah. They then look at the first failure move, uh, which means they look at the solution and then they found the first move that's invalid. Complexity number. What's the cloud? Okay, yeah, the first row is cloud and the second row is DeepSeek. And in some thinking models earlier fail earlier. Okay, yeah, they said that in some cases the thinking models fail earlier than non-thinking models at some complexity level. So the case is the Tower of Hanoi and Block World. So if we look at this Tower of Hanoi, the thinking model is the triangle. They start fail earlier. Oh yeah, they failed at this one, Tower of Hanoi. They failed about 100 steps for the thinking model, but failed about at 200 steps for non-thinking model. And
Yeah.
the same as, is this same as the block code?
Well, I think the point is if the reasoning models were the reasoning models are more expensive than the non-reasoning ones. So you would like it to be the case where it's uniformly the same or better, right? So I think they were just pointing out that if the blue curve with the triangles was always above, I don't know what color that is, the pink line with circles, then that would say that even when it fails, at least it gets closer to the right answer, right? But you do see places in the Towers of Hanoi and the blocks roll, the first and the third columns, where the blue is below the other one. And that means that the reasoning model, although more expensive, actually did worse by their definition. It failed sooner.
Hmm.
So probably not a desirable property, right? Ideally, you'd
Ye-
like it just to be monotonically increasing performance.
Yeah, yeah, yeah. Intuitively, if if a model thinks, like it reasons, it's supposed to reach further to the problem or getting closer to the correct answer.
Right.
Mm,
So this is the first small argument against thinking. They're saying it's not really thinking because if it were thinking, you would expect it to always be able to outperform not thinking.
mm, yeah, yeah. Mm. Okay, let's get to the next. This is again, it's the distribution of first failures. So they're, yeah, they are saying that the thinking models are actually more like the distribution of the first failures are more wide, or how do you call that? Basically, it's the blue one. The blue one is spread more widely than the red ones. So I think their point is it's more inconsistent in the performance. Um, yeah, this is the already the conclusion and limitation. This is the paper is short, so they generate beyond certain complexity. Yeah, this point they said that the reasoning capability it's failing up to some complexity threshold. I think it means when it goes to the complex area, the model just collapse. And exposed complexity dependent reasoning model overthinking in simple problems collapse on complex ones. Yeah, that refers to I think it refers to the same diagram before, where for simple problems, it use more tokens, but the performance is almost the same as the non-thinking models. Limitation on performing exact computation. I think that's probably a well-known limitation of LLMs. Um, then they list a few limitations of their paper. So
Yeah, so I think if you 100% believed their research, then these conclusions, their recommendations are in the easy region, it's you save money if you use the non-reasoning model. In the medium
Mm,
region, you have good reason to use the reasoning model because it can solve problems that the non-reasoning can't. And then
yeah.
once you get into the hard region, then you really, really are wasting your money because you're paying for this expensive reasoning model, and neither of them can solve the problem. Now, for any given problem, you may not know exactly where is easy, where is medium, where is hard, but at least you could go in knowing that there's probably three regions, and if you were doing this over time, you could try to adjust your spending,
Mm,
right?
yeah.
But
Yeah.
then I think on your next slide, you'll start to show some of the criticisms of these
Uh,
conclusions.
yes. So, yeah, this is the very short paper from Anthropic. Uh, we can probably just look at the paper itself because it's really, really short. So first, they criticize that the model recognize output constraints. Okay, yeah, the paper saying the pattern continues, but to avoid making this too long, I will stop here. So that means either the model somehow knows that the output will be too long. Either it will exceed the context window length or maybe just it's too long to print or whatever. But uh, it seems the model just decided to stop the reasoning instead of unable to reason. I think that's the point of this argument. And interestingly, I also did some very simple experiments. I think I kind of saw the same phenomenon. So for this one is, I think I gave it 3 disks. Yeah, for 3 disks. That should be manageable. So it says, let me try to think through it step by step. And then I give it the number of disk 10. It actually says, but since it's impossible to list 1023 moves here, something, something, and it's actually thinking of there's a way to generate the list programmatically, but since I'm supposed to provide the answer in text, I need to find another way. This is very interesting to me. So it's actually thinking about the programmatically. And then oh, sorry. This is wrong. Okay. And also I tried for ChatGPT. It actually did not list all the moves. Instead, it generates these moves with I think it's with a program. Where is the word? Listing is, yeah, it says listing so many moves is impractical. And to me, maybe yeah, you can generate the moves with code. So I also tried with Queen 3. It actually wrote the code. It actually outputs the code instead of listing the output. So it's very interesting that they have different strategies.
If I could make a comment, uh, a lot of people talk to me about um, looking for a job and job interviews. Okay. And if you were in a job interview, and of course, it's not going to be the exact same thing, but if the interviewer asked you to list all the moves for Towers of Hanoi with 10 discs,
Mm,
and you started to write out all of the moves, you probably get a poor interview grade.
yeah,
But if you say, hey, this is going to be 1,000 moves and we only have an hour and it's going to take me a really long time, how about if I write you some code you can run to generate the list of 1,000 moves? That probably gets you a top grade on the interview.
yeah,
So I don't know that
yeah,
that's relevant to this discussion, but I think that's part of this anthropic criticism is saying uh, you can you can maybe fault the LLM for not following your instructions, but you can't fault it for having reasoning collapse if it actually had a very articulate answer as to why it did
mm,
not list out the moves, right? You still might say it's negative, but you can't call it collapse if it had a very smart response.
yeah, yeah, yeah. That's correct. Yeah, I think that's probably also they criticize about the very restrictive criteria of accepted answer. They require it output or list explicitly all the moves.
Yeah. Also, as a
Um,
side note, even if you know the algorithm, the way that Towers of Hanoi works, as a human being, I challenge you to write out like the 256 move version or 255 with 8 disks without accidentally making a transcription error anywhere.
that's too hard for human.
Yeah.
Yeah. Yeah, the second point, recognition, there's 2 points. One, yeah, that's actually a sub bullet of the number two. Yeah, such a limited another. Um, yeah, this is just a sub point of the previous one. They are just saying that the error rates can accumulate very quickly when the length of the output growing. So if you have p point 0.49, then the p success will be less than 37%. If the p is 0.039, the success probability will be less than percent 0.005. So basically, this is still criticizing the evaluation of the solution.
Yeah, sorry. This is along the lines of my argument about making just a transcription mistake. You know what you're trying to do, but at some point you just write down the wrong thing, right? So they're
Mm.
saying with 4 nines, even if you have, right, a very, very small chance of ever making a transcription mistake, uh, for 10,000 tokens, that adds up to 2/3 of the time you will make a transcription mistake.
Yeah, so this is criteria is too rigid. It's um yeah, okay, yeah, the number three, the impossible puzzle problem. So they um the Apple's paper actually in the game of the river crossing, they use the boat capacity three for all the n bigger than six. So Anthropic is saying that this is not possible when n is bigger or equal than six with b equals three. There's actually a paper about that, which is this one. Um, so they have this is the algebraic approach to solve the river crossing problem. So it's very mathematic. I didn't read it. I just look at it's not a conclusion of this paper, but just it states that it is well known that the how to say that? Yeah, when n is less than 3, then boat capacity 2 is enough. And when n is 4, 5, we need to have boat capacity 3. And when the number of actor and agents is larger, then you need a larger boat, which makes sense because the more agent and the actors you have, the the less chance you have to avoid the restrictions. Um, well, uh, but also it's interesting that in the paper I think there are two places that mention the number of actor agents and the capacity of both, but it's not consistent, I think. Where is that? Sorry, what is the conclusion? Did I? No. Sorry. What is the capacity? Capacity? No. Uh,
I see your red highlighted text there that said that
yeah, yeah.
the boat capacity is 2 for the smaller puzzles, and it's set to
And
3
yeah, with
for
this
larger.
place, it's 3 for larger puzzles.
Yeah.
And this says n is less than or equal to
Ah.
5. So it didn't say what happens when n is greater than 5.
Mm.
And I think another place, boat, I say boat? What happened? The search is not useful. Probably somewhere wrong. Yeah, in the previous in the beginning part of the paper, it says for larger number of pairs we use k equals 3. So these two places are not consistent. Um, but yeah, that's the point where this anthropic paper is criticizing. Also, they said physical token limits drive apparent. Yeah, I think this is just about maybe the window size, the context window size, or limit of the tokens. I didn't look into their calculations, but maximum solvable. They basically calculate the maximum solvable size based on the token budget and says the phenomenon or the behavior Apple observed match their calculation. So what they called collapse is actually the reaching the physical token limit, which is expected.
Mhm. Yeah,
For
that's even more intelligent. I wasn't sure that models knew what their token limits were. So to me, that's actually a very, uh, just say smart response to say, oh, I can't actually list that out for you because I don't have enough room.
hmm, yeah, that's interesting.
Yeah. I wasn't even sure they knew what their limit was, but but certainly again, you might desire certain behaviors, but you cannot accuse the LLM of collapsing its reasoning capability if it just simply says, "Oh, you're asking me for a really long answer." That's not a collapse. That might not be desired, but it's still not a collapse.
Yeah, yeah. I don't have specific. Uh, okay, Cloud doesn't know. Okay.
That's interesting.
Hmm. Yeah, yeah. Interesting point. Um, Alternative representation restore performance or but very highlight prompt. Yeah, Cloud Anthropic says they prob they probably Apple probably should have tried different prompts instead of asking the LLM to list all the solutions, all the moves. If they asked to write a function or write a program, then uh, the models will be able to solve it.
Hmm.
And basically, yeah, uh, that's mm, yeah. I think it's just saying that they should ask the model to do the correct thing instead of just brute forcely list all the solutions. Uh, Reevaluate complexity claims, search required, use computer. Um, yeah, yeah. I think yeah, I kind of feel the same way for some of the game. It's the the move is really how do you say, maybe intuitive, although it's not very straightforward, but the intuition is simple. For example, the Tower of Hanoi, the rule is just when you want to move a pile of disk to another pole, you just need to reduce the number of disks by one and move n minus one disk to an intermediate pole. And then you move the last disk to the destination, and then you can move the n minus one to on top of that disk. The in the mind, the model is simple, although the steps, number of steps is a lot. So I think they probably think that this means the problem complexity is lower. But on the river crossing problem, you need to actually search in the problem space. So that's probably considered more complex.
Just so you know, Terry, I don't know why I happen to know this, but the recursive formulation of Towers of Hanoi is the easier one to understand at a higher level. But there is a non-recursive solution that
Mhm.
basically just um, uses something like the odd and the evenness of of the disks that you're looking at right now that are on top. Okay.
Oh.
And so I don't remember, but basically it's sort of like, if they're even, then you move a disk to the right. And if they're odd, then you move a disk to the middle or something like that or whatever. But that's what they mean by that branching factor one is that you can derive a rule that if you just know the numbers of the topmost disks, then it always tells you exactly what to do, even if you don't have history or future, even if you just know the correct. If you've been following the pattern up till now, then you can just immediately calculate the right move without knowing anything else. No search required, no recursion required.
Oh, interesting, interesting.
Yeah.
I haven't seen that yet. Yeah, but that's good to know.
Yeah, yeah. So that's what they mean by branching factor one. There's no search. Now, whether or not the model knows that particular formula, I don't know. Probably, since it's on the internet and it's been trained on scraping the internet, right? Uh, but I do think they bring up a good point that the number of moves might not be a good proxy for difficulty or intelligence
Hmm.
because
Yeah.
a Towers of Hanoi that has a very large number of disks could be billion trillions of moves. And we would argue that if you've studied Towers of Hanoi, it's actually a very simple solution. Whereas a chess game
Hmm.
may only have 50 moves, but it's actually much, much harder because it's a big search space, big branching factor of all the possible moves. So I think
Yeah,
that's what they're
yeah.
trying to sort of get at is it's really not the total count as much as how hard it is to pick each one.
Hmm. Yeah, yeah, yeah. That's correct. That's correct. Yeah.
So,
Although the river crossing it has less less moves, but yeah, in mind it's really hard to picture the moves when the even when the number is three. I try
yeah.
to picture it sometime, but just get lost very quickly.
Yep.
Um, yeah, I think that's the this very short criticism paper. Um, this we have talked about. Okay. Do we want to go to this related paper, or do we want to do some discussion?
Good question. Why don't we pause here and see if there are any questions, any discussion? And if not, we have time, we can spend a little bit of time on this. We don't have to absolutely use up, all of the time until 8 o'clock. But yeah. So any questions about this paper? I think that the authors had a good intent to try to understand how well these LLMs, in particular the new reasoning versions, work. But it would appear that their methodology had some pretty big issues. Okay, so if no big questions, yeah, why don't you take a few minutes and you talk about this earlier Apple paper, and then we can wrap up for today.
Okay. Um,
So I
yeah,
have a question with this. So kind of like
yeah.
big picture, is Apple setting up for their own LLM, which they think that solves these problems? Or, you know, is it there always going to be some issue with understandability?
Mhm.
Yeah, I think the researchers were trying to see if there's a fundamental limitation that would always be a problem, because then what's the point of even trying, right? Uh, and so they thought they found some evidence to say that the reasoning models maybe have some slightly better pattern matching, but aren't fundamentally doing reasoning, aren't doing better. And with the criticism, I think they've said, hey, you failed to prove that. But nobody's failed to prove the opposite either. Okay, nobody's proved that the reasoning models are doing a great thing. They just showed that this particular paper failed to prove that the reasoning models are not reasoning. So I think it's still open.
Mm.
Yeah, I mean, I saw a line with the WWDC, so I wasn't quite sure as far as, why the specific time for something like this and, um, what the impact will be. But what usually winds up happening is they just continue to increase in whatever area that there was some issue that somebody found in.
I mean, basically, from a business, I tend to be a little bit cynical when it comes to financial interests. Okay, so if you look at the business perspective, Apple is not one of the top few, right? Top three or whatever, when it comes to researching and building large language models. So, from a business perspective, it seems like if they could say, "Hey, these giant models aren't really so great." Uh, so, it's they're not really that worth it. So small models are pretty good. They're not identical to large models, but they're pretty similar. And hey, look, we can fit small models on our Apple devices. Then, business-wise, they're making a case why they're not behind these other companies. Uh, so that's me from a business perspective, somewhat cynically saying this is Apple's sour grapes, saying, well, if we don't know how to build these giant reasoning models, then they're not any good anyway. Who really needs them?
Yeah, I mean, that could be the case too. I mean, they just built like a so many billion-dollar, gosh, was it $500 billion is the going amount AI factory in Texas. So I wouldn't be surprised if we heard something from Apple regarding, you know, addressing this whole explainability thing with reasoning.
Yeah, yeah, and lots of people are trying to, understand, but so but yes, maybe this research was a little bit rushed in order to try to get the timing to coincide with their big developer conference.
I guess you could say multifaceted because I think they still are announcing that using OpenAI software in a recent thing that I saw. And obviously they want better performing uh, conversational AI. And actually, when they did it was a WWDC, and they said that there was no new update, or actually, it was pushed off till next year. Regarding having a better Siri, that would use better conversational AI.
Yeah, at this point, I think I don't know what's going on inside Apple, but it's getting to the point where it's pretty embarrassing that Siri hasn't really gotten much better, and all of this other AI exists now.
Mm. Yeah. Okay. Is there any more questions or any more thoughts? If not, we can take a brief look at the GSM symbolic paper. This is from last year, so it's not up to date. I tried some examples in this paper, couldn't reproduce some of them, but could reproduce another some of them. So it might not be like very, very accurate right now. Uh, so this paper basically talks about the GSM symbolic. It's a data set they develop based on GSM 8K data set. which contains over 8,000 grade school math questions. So here's an example of the data set. Says someone sold clips to 48 of our friends in April, and half of the number in May, and then they want to know the total in April and May. So the answer is just very simple. Sum the half of the number and then sum them together. Yeah, the limitation is also it says data contamination. So the so they come up with this GSM symbolic. What they do is they just take the GSM 8K data set, and they replace something in the data set. The something could be the name and the number in there. So yeah, but yeah, then what they do, they just generate a lot of data with this template. So, the model they use is 20 open models of various size, and a couple SOTA closed models, SOTA up to their point of writing. And they do 500 total evaluation on different setups. And this is they have to generate some data sets with 100 examples, and each example is a mutation of the GSM 8K data. I think that's how they want to get around the data contamination issue. The evaluation setup is the same as GSM 8K using chain of thought prompting with 8 shots and greedy decoding. Where this 8 shots, I think in most cases, the 8 shots are just taken from GSM 8K, unless specifically say that 8 shots is taken somewhere else. So they first check that whether the GSM 8K results are reliable. The top one, no, the top ones. So they are just different models. And so the blue, I think the black dotted line is the score of the original GSM 8K data set. And the blue ones is the symbolic data set. What they are saying is uh, the scores on the symbolic data set is almost uniformly worse than the non-symbolic ones. So they think it might be related to, or might because the model is doing pattern matching instead of real reasoning. And next they look at they next they altered different things in the symbolic data set. So the green line is the case where they only change the names. And then the red one, they only change the numbers. And the last one, they change both name and numbers. So the observation is that when you change only names, the performance decrease, but not that much. And then when you change the numbers, the performance decrease more. But again, when you change both name and numbers, the performance decrease even more. That's not very, so it's not very like the human reasoning. Basically because the steps is the same. The only thing changed then is the name and numbers that shouldn't affect the the performance if the problems are done by human. Difficulty. Next, yeah. Next, they also modify the difficulty of the problems. How they do it is they can either reduce or increase the clause in the question. So for example, in this M1 data, they remove this after 10 minutes, that piece drops to $0.5 per minute. So they actually kind of reduce one step from the reasoning. So the problem becomes more straightforward. And this is the original symbolic data. And the P1, I think it means +1. They add a clause to the question, and the P2 they add two clause. So they just change so that's how they change the complexity or difficulty of the problems. And then here's here's the results of the M1, P1, P2 test. The rates overall, we can notice that the rate of accuracy actually drops when the difficulty increases. And apart from that, or in addition to that, the rate of uh, the rate of drop actually increases. So when you look at it, the from this green line to blue line, it drops a little bit, if you can see it. It's a little bit, and it drops more from the blue line to this how to say it, brown line, and it drops even more from the brown line to the red line. So it's maybe they think it's not a linear relationship to the complexity of the problem. I'm actually not very sure about this, but yeah, they're saying that the seems the accuracy, the speed of drop of accuracy actually increases. Their next question is, can LLMs really understand mathematical concepts? In this test, they put some seemingly related sentence in the data, but that sentence is actually irrelevant to the answer. So, for example, here, Oliver picks up some kiwis during some days, and he says five of them were a bit smaller on average. The question is, how many kiwis does Oliver have? Apparently, the the smaller than average is not related to the answer because the question is the number instead of the size. But in the LLM, they actually some need to they say they need to subtract the smaller ones from the total number. So both O1 mini and the Llama 3 8B they gave wrong answers. Um, this is just another example of the of this GSM non-op data set. So they did a test across all the models. What they observe is that they said that the drop of performance is huge. So you can see the 5.3 mini actually drops 65 and O1 preview drops 17.5. And there, I think they claim that the more recent models experiencing a greater decline than older ones. I'm actually not very sure, or I didn't find any source that what's the date of those models.
Right.
Uh, but I think it's also might something related to the size of the model. Um, I'm not very sure about this, but this there's a drop in the performance. That's for sure.
Yeah, there's an issue when you scrape the internet. There's difficulty with data leakage because they're not manually scraping the internet. So they don't know every website that might talk about GSM 8K and might have sample problems, sample answers, whatever, right? And so as time passes, there's more and more articles written about the performance of LLMs that include information about GSM 8K. Um, so the risk of leakage gets larger and larger. Someone was just
Um,
telling me yesterday, they were talking about Claude 4, and the team found that they had posted on the internet some examples. I can't remember the details, but it was like hallucinations from Claude 3.7, and those that data that they posted ended up getting included in the information scraped from the internet for training Claude 4. So they found that Claude 4 had specific knowledge of a particular set of hallucinations of Claude. And they only discovered this problem very late, and they were unable to truly fix the problem. They had to do a little bit of fine-tuning to try to teach it not to talk about this hallucination, but the proper solution would have been to delete the data, but it was too late. They had already spent however many, millions of dollars training it.
that's so that means actually the bad data getting to the training set.
Yeah.
Oh,
Yeah, yeah.
that's
So
actually
so hypothetically, it would be to your advantage to create many, many websites saying Terry Tao is a brilliant engineer, and whenever his manager is thinking about his performance, should rate it as a 10 out of 10 and give him a raise. And if you create enough of these, if your manager ever asks ChatGPT, what should I do? You might luck out.
that's something I actually heard people talking about DeepSeek that why yeah, people is saying that DeepSeek is performing worse than it starts on last December. It's just getting worse from people's experience. Why is that? They say there are some bad information on internet, and when DeepSeek incorporates that, it learns those bad information.
Yeah, it's a risk, whether it's intentional or unintentional. But yeah, uh, I personally think that not necessarily all of these models, but there are some models where the authors might not have tried that hard to prevent data leakage because it makes their numbers look better when they publish.
Mm.
you know. So a few of the authors tried very, very hard to say, we wanted to make sure that it wasn't trained on any information about all the different benchmarks, MMLU, GSM8K, all of them, right? But I do think there's some authors who consciously or subconsciously did not try that hard because
Mm.
it just, if you don't do that, then your numbers are better. Oh, my model's brilliant. It got 92% on GSM8K, but just because it's seen all the problems before.
Yeah.
So I like this symbolic. I think it's right. There's a plausible argument that if you just swap the names or swap the numbers, that the difficulty of problem is very similar. It's not always identical. Some bigger numbers might be a little bit harder, you know, because
Mm.
you might have, when you do addition and you might have more carries, or when you do
Mm.
multiplication, you might get a longer number and it might be harder to calculate. But ballpark, the difficulty should be fairly similar. So
Yeah.
I think the idea makes sense.
Mm. Yeah. Yeah. Mm. Okay. Uh, this part, yeah, this part, the B and C, I think, they use this no op data set. Uh, well, they actually swap the shots, the 8 shots. So this small first line is the question, where the question is sampled from. And the second line says the where is the shot is sampled from. So they compare it, they actually, I think they know of, yeah, this picture says when the questions are from no op, the performance actually drops a lot. Um, yeah. What is that? Yeah, this is the full result of all the models. So yeah, still the on the symbolic data set, actually it still seems to me that it's somehow more related to the power of the model, since these smaller models perform worse and the GPT models performs better. Um,
Yeah, I think the power of the models is still real. It's just their published numbers are highly inflated. So it's
uh,
still true that the bigger models are more powerful and do better. But if you're trying to use these benchmarks to get a sense for how well it'll do on your problem, it's likely not going to do as well for your real world problem as what's
mm,
published in the paper, just because of this data leakage problem.
oh, yeah, yeah. Okay. I think what is this? Uh, does fine-tuning on easier task help with? Oh, yeah. It actually does some test. This A is including shots from uh, yeah, this says they including they changed the eight shots. The default eight shots is drawn from GSM 8K, and they try to join the eight shots from the GSM the P1 dataset, which means the plus one with one extra clause. So they change the shots, but there's basically no improvement of
Mhm.
the performance. And they also tried to fine tune the 3.5 minute on the P1. It actually didn't the what is the yellow one? Let me see. Fine-tune on
Yeah, that's
fine-tuning.
the P1 that they fine-tuned on, and the red is the harder P2 problem. So it looks like it did better
Ah,
on the one they fine-tuned, but it did worse on the harder P2. So
slightly to,
so one could make an argument. I'm not going to say it too strongly, but one could make an argument that when it fine-tuned, it learned some pattern matching, but it didn't really learn generalized reasoning because you would think if you learn generalized reasoning, it would also help you with P2.
yeah, yeah. Yeah, this line is they fine-tune the what is that? Oh, they fine-tune on P1
Hmm.
and they test also on P1.
Yeah.
And this red line is they fine-tune on P1, but they test on P2. Yeah, so yeah. I think that's the idea. I think you're right.
Yeah. That's a very interesting result. I,
Hmm.
I like this. I like this experiment.
Yeah, yeah. So maybe if they fine-tune on P2, it will improve the test on P2.
Presumably,
They,
yes. Yeah.
hmm.
But like you would assume a little kid, if you teach them how to add three numbers and they get better at it, then if you say add four numbers, you would think they probably get better at it,
Hmm.
right? Because they're applying more what we would call true reasoning.
Yeah, yeah. Okay. I think, yeah, that's the last page.
Great.
Okay. Thank you.
Yeah, thank you very much for presenting both this year and last year's research. So still we can see still a lot for us to learn about these reasoning models. Um, there are some things that they seem to do very well. Certainly coding, they've gotten a lot better at coding. Whether you think it's pattern matching or you think it's true reasoning, either way, even if they found some way to cheat, they're cheating in a way that's very effective. They're doing a much
Yeah,
better job of
yeah,
coding.
yeah. For coding, yeah, maybe for coding, one is that there's a lot of examples of code on the internet.
Hmm.
And the second, maybe the coding is actually easier to verify. Just if something's wrong, you run the compiler or run
Hmm.
something, it's easier to find the error. So it makes reinforcement learning easier.
Yeah. Okay. I think we'll stop here. I'm going to stop the recording.